Good morning, friends. Welcome to the series of Spring Cloud Microservice. This is the session 1 in the whole series. In these sessions, I'm going to cover how you are going to use Spring Cloud and Python, both the programming languages, and develop microservices applications. So these sessions primarily focus on coding aspect. I'm not going to dwell in depth about microservices architecture, why it is needed and stuff. I'm going to cover them at the top, but not in a very depth. The primary focus of these sessions are for you guys to get hands-on coding microservices and deploy them on various technology stacks that are currently available. Starting, it can be from your private cloud, Google Cloud, Amazon, or on Pivotal Cloud Foundry, various offerings. So mostly you'll get an hands-on experience by following this series. So without wasting much time, let us start the session 1. The session 1, in this session, we primarily focus on building a microservice, your first microservice. So I'll go through what is a microservice, okay, and little bit of advantages, principles that you need to follow while you're developing a microservice. Then we will take one simple employee application and build that. Okay, let us jump. Okay, so the first thing comes into your mind is what is microservice. The name itself says microservice, right? What is micro means small, and service means do a service to you. Okay, developing a service, or doing some small responsibility. Okay, micro is small and service. The name itself says that when you develop a small application, it should do only one job. It shouldn't do the 100 things. For example, let me go to the drawing board. Let me create a new board. So we have an employee application. Okay, it's nothing but employee management application. You can think it as employee management. Like when a new employee joins, certain things, employee details are stored here. So an employee management application has these details: employee name, employee salary, how much salary he is drawing, and how much insurance benefit he is having from the company. For simplicity's sake, these were the three things that this employee management applications do. Whenever a new employee comes, we'll add those details. Whenever it leaves, we'll delete. When there is an update in the insurance, we'll update. If there is an update in the salary, we update. If there is a name change, we do that. Okay. All CUD. Okay, we call it a create, read, update, delete operations can be done with this employee application. So if 15 years back or 20 years back, when these applications were developed, we follow a n-tier architecture. So we call it as an n-tier architecture. Okay, I'll explain you what is that. This application needs an UI, right? We will have one UI layer. Then we will have one business layer. And then we used to have one data access layer. Then we used to have one database. Okay. And then we used to have browser. People used to use browser and access the UI, and that used to happen all the way. So this is how we used to develop applications. This we call them as monolithic architecture. What is meant by monolithic is like we all run this under one process. Like if it can be a Java application, it can be a .NET application. We don't, but we used to break them into layers, like 3 layers we have, right? One is UI, then you used to have 3, and 2 is business, and 3 is data access layer. This is considered to be very good architecture those days. Okay, even now it is good. Several good applications run on top of it. So I'm not going to go into that debate versus monolithic versus microservice. So this is how you build a single monolithic application. Monolithic is one single, in one single process it runs everything. Now this, with the advent of cloud, with the so many needs, right? If you want to scale up application, what you used to do, you used to deploy another instance of it. Then you used to increase RAM. Then if data is base is a problematic, you used to increase database capacity and stuff. Now, to overcome all those, now people are saying microservice architecture. Okay, now let us try to split this entire monolithic into microservice architecture or microservice based. Essentially, it's an employee application. You are moving it into from monolithic architecture to microservice architecture. That is what you are doing. So now the first layer is I'll write one UI microservice. Okay. The second thing is, now here comes, you don't think that we'll develop one business layer microservice. No, we will develop one employee name microservice. Okay, which will only saves employee details, employee first name, family, blah blah blah, whatever, employee name service. And another microservice will do an employee salary, it will manage. Okay, and another microservice which we have will manage employee insurance. So this is one thing which you need to understand. Okay, we are not breaking that UI into one microservice, business into another microservice, and data into another microservice. If you do that, then you are shoot on your foot. Okay, so you are doing a bad architecture. So I'll come why it is when you are learning about principles of Microservice. The whole idea is like, we will take the business functionality and break into microservices. Business is most important, not the technology. Okay, so you take the employee name, you'll split into one salary service and insurance service, like, and each one will have its own database. I'm not saying that we shouldn't use database. So each one will have its own database and manage the employee details. Okay, like this. Each one will have its own DB. Sorry, here it is DB. Here it is DB. Here it is DB. And here it is its DB. Now, so these all UI is going to communicate with these three services, and user is going to communicate with using browser with two UI service. This is what a microservice architecture. You are breaking the responsibility of employee details into three applications, and they collectively combine together and serve the employee management application. So you are breaking it into employee name service, salary service, and insurance service. That is what we did. So now my next question you will ask me, these all services needs to be built with one technology? No. So here what I did in the example which I'm going to present now, I did the insurance service in Python. So based upon, and the rest of the services, I did it on Java. Okay, based on your technology need, you can choose the technology. Sometimes you feel that, okay, insurance service is easy to write in Python because there is a good amount of libraries available to do that. Then you write it in Python. Someone feels that Node.js is better, you can write it in better UI, you can go for Bootstrap. So one technology you need not to limit. So microservice, when you're developing a microservice, you shouldn't stick to a particular tech stack. You can easily swap these layers. Okay, so now you first understood why do we need microservice, right? To take the benefit of scalability and cloud offering. Like now the clouds are coming up, the cloud technologies are maturing, not maturing, it's they're already mature. So you can easily deploy and manage those microservices easily on the cloud. Okay, now what is a microservice? A microservice handles a single responsibility. So let me present once again. So we went through what is microservice. Sorry, we went through what is microservice. Then why do we need microservice? Better management of applications, scalability, and you have to move with the trend, what's going in the industry, right? So so that your tech stack is not obsolete and you can easily manage you understood what is monolithic and microservice architecture. If you see the screen, this is the difference between this. Left is monolithic and right is microservice architecture. And principles of microservice. So if you ask me what are the principles of microservice, then these were the three important things which I'll say. Single responsibility. For example, the employee name microservice should only responsible for employee details, or I should say employee details microservice should only be responsible for employee name and his first name, last name, and his family details, and blah blah blah. Employee salary service should be responsible for his salary management, and insurance is for insurance. So it's not that one service, one microservice should do so many things. It should have only one single responsibility. Then it's very easy, right? People can focus on that. If you are given a single responsibility, you excel, right? The same concept there, okay? If you are giving only one responsibility, the service, it's very easy to manage. It's very easy to change it and adapt and stuff. So the common layer, right? If you are developing a big monolithic service, if you change employee details, you never know what will break, whether salary service will break, but here that doesn't happen. So once again, I want to myself, I want to my, sorry, if I want to restrict myself from not going to literature and advantages, you can get it on internet. Our core goal is developing and quotes on hands-on. Built around capabilities. Very important thing is you need to build around capabilities, not around technology stack. Okay, I will say database layer as one layer, microservice I'll build, business layer as one microservice, UI as one. No, you have to build around the capabilities. You build it, you own it. So what you mean is people who are developing microservices should own it till the production level. I really liked one article in the internet which covers this pretty well. I referred in my blog as well. So how to do it in Java? If you go to this web page, it was nicely covered. No nonsense. Okay, you can easily understand it very well. So the entire session, what you are going, the entire code, video, you are going to get it in my GitHub repository, Spring Cloud Session1 microservices. There will be a series of sessions which covers the microservices from zero to hero. So you will learn from developing. If you don't know about any microservices, you can learn from here until you deploy to the production and manage, monitor. I cover all aspects of it in a series of sessions. Okay, now let us go and understand our first microservice. So that was bit background. Now let me say you what is the first the employee management application. Like whatever you saw here, right? This employee management application, I'm going to build three microservices. First one is employee API, which will give employee API developed in Java. Second thing is salary API, which will give it in the salary application, which is developed in Java, and insurance API, which is developed in Python. I didn't develop UI as I showed there, and I didn't develop an API which communicates where a microservice communicates with another service and stuff. We are going to cover that in the further sessions. Okay, so all we were going to do is you call an employee microservice and get employee details. You call insurance microservice, get insurance details, and you call salary microservice and get salary details. Those were the two things. I'll go through a demo and walk through. Okay, let us try to understand the environment. That's utmost important. Okay, now, so I have employee API, which is running on, it has a DB inside it. Okay, I really don't have a database, but I just have, which is running on the port 9000. Okay, similarly I have, which is developed in Java. Similarly I have a payroll API, which is developed in Java, and once again it is running on 9010 port. Okay, similarly I have insurance API, which is running on 9020, which is developed in Python. Okay. So another new term I'm going to bring it here is like I have another microservice, which is I call it as a gateway. Sorry. Another thing I call it is as a gateway, which is running on 8080 port. Okay. So gateway is like, right? Gateway, when you have a building, a series of you have series of houses in a community, you have a gateway. People who comes via gate and go away that gateway. The same thing in that way. Gateway offers several services. There is a one tutorial which I made on gateway. What is the difference between a gateway, proxy? You can go through it. But simple thing is like browser. You have a browser. It can be a or browsers like Chrome or Firefox, or you can use curl, anything. You call the gateway, and gateway talks on behalf of you to employee API and returns back the response. And same thing is true for payroll API as well. Okay, and same thing for insurance API as well. Okay, now let me call this as an employee application. Okay, so gateway is running on port 8080. This is on 90909020. We call gateway is also a for example, gateway is also developed in Java, and gateway we call it as a reverse proxy. Okay, so now you understood the architecture, right? You call gateway, and from gateway the data comes to you, the employee API, payroll, and insurance API. These three are microservices. Essentially these four are microservices. Three are developed in Java, and one is developed in Python. Okay, so now let's jump on to running this microservice, running this employee application, playing with it. Later we will do a code walkthrough. So this entire code is there in my GitHub repository. You can just clone it. When I am covering the code, I'll explain you the code walkthrough. Okay. Let me go to the shell. So if you see here, there are few tabs. The first tab, I'm going to build the code. Second tab, I'll run employee API. Third tab, payroll. Fourth tab, insurance. Fifth tab, gateway. And in the sixth tab, I'm going to call these services. Okay. So I use curl or I use postman. So even you have this postman scripts in the source code, you can download them. Okay, postman is a very simple utility to send HTTP request and view the response and send everything. So if you're not comfortable with curl, you can take my postman collection. Collection is nothing but a set of commands. Okay, you can take my collection, import it, and play with in the API. So the first step, what you need to do is you need to build the code. Very common thing, maven clean install. We are building the microservices. Or I'll just little bit, I'll do a clean and I'll show you the microservices code organization. Okay, so I have, if you see here, right, I have employee API, gateway, and insurance API folder, and payroll API. Each and every folder, it has its own code. Okay, so employee API and payroll API are on Java. That's the reason you are seeing this big path. But insurance API is built on Python, and gateway is also built on Java. So that is what I want to show you, the code organization, the main three. It's like multi-module Maven project. Leave about it if you are not good at Maven or something like that. You follow the steps, play with the code, and even if you are a system administrator, don't worry. You just get the code, build the code, and run the applications. Even you don't understand the code, that is fine. So now I'm cleaning and building the artifacts for it. The artifacts are not there in the repository. Only the code is available in the repository, Spring Cloud. Now let me bring the employee application up. So Java, if you see here, Java jar, this is what an employee application. So you can use java-jar and run the artifact, employee artifact. The employee application is up and which is listening on the port 9000. So it should be somewhere mentioned here. Okay. The server is using 9000 port. You are seeing here, right? The employee application is running on port 9000. If you want to access employee application, the simple way what you do is like you do a get call, like localhost, like employee API, which is running on HTTP localhost 9000, and you are passing employee ID and you are getting employee details. For example, let me send this. If I send employee 100, his name is Alex and his ID is 100. So you either use Postman to call the API. So essentially you are calling this API. Okay, and this is the response you got. This is a JSON response you got. Now you can do the similar thing with curl also. So if you say curl, you do this. Okay, you can see here the response you got. Curl is like command line URL. It's like browser only, where API testings people use curl more. Postman, curl or Postman is very popular. People who develop APIs to test. Now the same thing you can do from browser also. Like the browser also, when you pass what is the employee name with ID 100, it gave you Alex is his name. So that is what an employee API. The responsibility is to give only employee details. Similarly, I'll bring the rest of the APIs up. Like the next API in the series is like the payroll API. The same thing which you can do Java jar payroll API. The payroll API brings up. The next API is like insurance API. So this is slightly a different way. This is like a Python code, right? You have only one insurance.py pip file unlock. I gave you this. How do you run? My block contains everything. So the simple way you can raise pip env. Very common people run is Python run insurance.py, but pip env is a dependency management tool like Maven. It's very easy. You can say pip env run and insurance.py. It is going to run the insurance API. Okay, now insurance API is also getting started and it is listening on 9020 port. Payroll API also started, which is listening on the port 9010. See here, the payroll API is listening on the port 9010. Now we have all the applications running 1, 2, 3. Now the last one is like I have to run gateway. Let me start and run gateway also. Okay, gateway is coming up. Guess what port it binds? You're right, it binds to port 8080. Gateway is running on 8080. So now you see here the gateway is running on Netty 8080. When I go through code walkthrough, I'll explain you the technologies that were used, but I want to make it simple. So now what we will do is we will access the APIs via gateway. So like curl 8080, you are getting an, what you want to know, what is the salary, sorry, what is an employee details, employee name with 100. So you are calling an employee API. So the gateway gets that request 800 and talks to a employee API, takes the response and give it to the curl. So this is what the flow is happening. So the first call, if you see, the request comes from curl to gateway, or for you to easy. So this is what happening now, and it is going to employee and it is coming back and gateway is giving back to the curl. So this is what happened now. So when you run this simple command, employee localhost 8080, you have a gateway which is forwarding it to employee, and the response it collects and send it back. Now similarly with the payroll, so now I have employee, now I'll call payroll from gateway. Payroll, it's also same thing. So the payroll says that employee with ID 100 is 65,000 US dollars per annum. So this is what it is saying, payroll slash 100. Then the third API let me call is like insurance. What is the sum insured for this person? It can be a medical insurance, for example. The medical insurance for which he is insured is like 10,000 US dollars. So this person is insured for 10,000 US dollars. So this is what four microservices you built, and you are calling them via gateway. So this is what you achieved in this session. You built four microservices, and via gateway you're going to call them. Okay, no one directly calls microservices in the real world. So like no one directly calls payroll directly. So for example, if you try to do this, for example, insurance is running on 9020, right? So if you do like this, it's a wrong pattern. Okay, but still it works, but you don't expose your microservices directly to the environment. You expose it as an application via gateway. Okay, so using gateway, all the microservices are exposed via gateway. Remember that one thing very well. Gateway plays a very critical in the microservice. It's not only exposing service, but inter microservice communication. There are several things which you can achieve with the gateway. That's the reason gateways are very popular now. Gateway, the roles of gateway I covered in my previous sessions. I'm going to share you the link. So now you understood the whole thing. Let me go back to the code, because code plays an important role here. So let me start with employee API. Okay, let me just start with the employee API. You know, right, employee API is a simple Spring Boot application. If you see, employee API is a simple Spring Boot application, and I'm running it. It's nothing complex. There is an employee controller. Okay, so if someone gave employee/employee ID, I want to return the data of that employee. This is very simple REST API. You see, I have Alex with ID 100 and Tom with 100, and I have a map as a database, because I don't want to make this entire thing complex to use external database. I am using just a hash map as a database and getting data from database get by passing employee ID. So this is what an employee REST API. Employee REST API is taking employee ID and returning the details of the employee from the database. So for example, if you gave like it is running on 9000 port, right? So employee API is running on 9000 port, and with a context employee, and if you pass 100, it is giving Alex 101, it is Tom. Okay, with the so employee with ID 101 is Tom. So this is what happening. This is what an employee database, and it's a Spring Boot application. Nothing. It doesn't. It's a simple Spring Boot application. You are running it. Similarly, you have payroll API. I'm not going to go through that. I'll go through the insurance API because the people want to know Python. So here I used Flask, and similarly the database is a dictionary, map, anything. So which will has ID and the details. I used a simple dictionary to present the employee object. If you see one big difference here between Python and Java, here there is a model object. Here I don't use a model object, I use the dictionary to do that, because I want to write it. This is a hello world, right? And I said someone pass with an insurance/insurance ID, you just return that from the database. So database.get. And you can see this app is running on binding to any port and binding to any adapter, and it returns, and it is binding to 9020 port on any adapter. So Any adapter means it's like ETH card. You can bind to um, every ETH card will have an IP. I'm going to cover that later. So, but you can easily find it out. So your application can bind to a particular IP on your host, or it can bind to all the IPs on the host. It can serve for all the IPs in the host. It is returning. It is running on the port 9020. So now this is what code walkthrough of it. If you see the POM file, it is a multi-module Maven project, which is based on Spring Boot. Okay. Now let us go into one important component is gateway. So you guys know what is a gateway, right? Gateway is like all the requests are coming via gateway. It is like Spring Cloud Gateway. So gateway is a Spring Boot application, but essentially it is like Spring Cloud Gateway. This is, I added an dependency called Spring Cloud Starter Gateway. It is Spring Boot application, no doubt, but it is a Spring Cloud Gateway, which uses Spring Cloud Load Balancer to do client load balancing. I'm not going to cover this. There is a one video specifically made what is client-side load balancing, what is reverse proxy and stuff. You can go through it. But simple way to understand is all the requests are coming to it, to the gateway, it load balances, it sends to the particular microservice, it based upon various parameters. Okay, it playing a reverse proxy and it playing a role of a load balancer as well. Okay, so Spring Cloud load balancer is used here. The whole logic, the whole crux is here. Someone call with employee URL, right? So I'm going to not cover routes, predicates, filters. Okay, this is too much to cover, but my successive session will cover. So all you understand is like with someone call employee slash anything, give it to 9000 to the API employee API running on. If someone call payroll slash star something, give it to payroll API. Someone call insurance star, you are running it on insurance API. The good part is that insurance API is Python, but the Java is able to do a reverse proxy. So that's the beauty in HTTP world. Okay, so it's like platform agnostic, client agnostic. When inter microservice communication comes, how microservices communicate, this is essentially a microservice communication only. Gateway is communicating with employee and employee is communicating with gateway, and the result is sound back. It's like inter microservice, in between services communication using HTTP. Then there is a synchronous, asynchronous mode of communication. I'm going to cover that in the next session. So, and if you see the port, it is running on 8000. Similarly, I'll show you for the employee API also. This is for the gateway. Employee runs on 9000 port, nothing difference. Employee is running on 9000 port and gateway is running on 8080 port. Now you got that whole architecture, right? Now, what is a disadvantage with this? So now the important things which we need to discuss is, okay, you did very well, great code walkthrough, we built microservices, what is a disadvantage? How do you scale up applications? Like if someone say that, okay, employee details is taking so much time, can you bring one more instance up? Okay, can you bring one more service up? So this is having a performance issue, you want to bring one more instance up. You can simply do that. You just run it one more instance, like let me run it on one more instance of it. Okay, so the way you run it is like java -jar -d server.port equal to, I'm going to run it on 9030 port now. New instance runs on. So employee target employee API. Good. This is how you can bring one more instance when you, so that you can only bring the employee details application up on port 9030. When you did that, Now what we did, now here we got one more instance up, okay, which is running on employee API on 9030 port. This is good, but where is the link with gateway? Gateway has to send it, right? So that you need to edit the file, configuration file needs to be changed. You need to restart gateway, which is a bad. So we are defeating the purpose of microservice architecture. So this hello world is not there are some other things. Okay, applications are binding to static port. See, I don't care which port the application runs. Currently, it is running on 90301020. Why? Because user is accessing via gateway. Why do I need to know where the application is running on? Why it can't take dynamic ports? I really don't care on which port the REST API is running. So dynamic ports is important thing. Microservices binding to dynamic port size, why is important. I'm going to cover in next session. Similarly, there is like discovery registry, which we are going to cover in the next session. So this is what I'm planned to cover. I think yes, this is what I plan to cover in this session. Download the code, play with it. The entire documentation is available in the GitHub repository. Hope you liked my video. Follow the success sessions. I think roughly that there will be around 12 sessions, which covers entire microservice from zero to hero. Okay. Thank you very much.